Okay, so we are starting 2.2 today. And the very first question says, without using technology, match each of the equations with a graph of the function. Be careful, there are more graphs than equations. 1, 2, 3, 4, 5 versus 1, 2, 3, 4. Okay, so I'm looking at what you all did, and you all put different numbers in there. We have some consensus. Look, like these people all said 2, 4, 3. This person said 2, 4, 3. This person said 2, 4, 3. So we have some consensus 2, 4, 3. So I want to make sure that you guys are all getting this right. Again, your job is to not be like, oh, I know how to do this perfectly. Your job is to make mistakes so that you can learn how to get it right. Okay, so let's get started. Okay, so first question said x squared minus 3. So again, keeping track of participation points. What does that minus 3 do? What does he do? What is he in charge of? What kind of movement is he in charge of from last time? Do you guys remember this? From last time, what kind of movement is he in charge of? Yeah, it's definitely a negative. But my question is, and then can you guys be comfortable? Yes, thank you for chatting to the big group. Very good. Yeah, going down. A lot of you said going down. Now, here's how I know it's going down. Actually, I'm not answering that. You answer that. How do you know? Sorry, that's my cup. How do you know? I'm trying to take participation points. How do you know it's going down 3? How did you know that this guy means down 3? A bunch of you said it. How did you know? Very good. Very good. Got a lot of different responses. Look at some of those responses. If you can be comfortable in chatting to the whole entire group, not just to Miss Johnson. Miss Johnson actually knows it. I tell you guys to chat to the whole group because I want everybody to see, oh, they can do it. That means I could do it. Yes, absolutely. That's exactly what that means. So the specific response, like a complete whole response that I was kind of looking for, was kind of like this, right? Miss Johnson, this -3, I'm going to blow this up just a little bit. Yeah, this -3 right here, Miss Johnson, goes down 3. Now, why does it go down 3? Why does it go down 3? So we talked a lot last time about something inside the parentheses versus outside the parentheses. We talked a lot about to the x versus to the y. So I know this goes down by 3 because it's affecting the whole function x squared and not just the x. So down by 3 because it is -3 to x squared, not just to x. Not just to x. Does that make sense? See how this one over here is just to the x? This -3 is just to the x. Does everybody see that? So this, what is this movement going to be? What is this x -3 in parentheses? What kind of movement is this going to be? In the chat, y'all. Okay, so one more time. What is this -3? What is his job? Like, I think about these as directions. What is this telling my parabola to do? Because this is also negative. Yeah, this guy is, say, move right 3, move right 3. Now, if you don't know, the reason why this one's move right 3 is because of 2 things. Number 1, very good, by the way, very, very good. Number one, the reason why it's telling me to move right 3 is because if you remember the X, remember I told you X lives in the land of what? What did I tell you X lives in the land of? X is always going to be what? Does it listen? Yes. Thank you. That's what I wanted. It's always backwards or it's opposite of what you think. Remember we talked about like when they live in opposite, when it's opposite day, left means right and right means left. Well, negative usually means to the left, but because it's happening to X, they live in opposite land or backwards land. And so they move right 3. Does that make sense? So interestingly enough, I'm teaching the same exact concept in integrated 3, except we're not using parabolas. We're using a different function and the concept is exactly the same. So if you learn this, you are making it easier for you next year in integrated 3. Does that make sense? So keep that in mind. Exactly. So even though it says -3 to the X, because I know it's happening to the X, I don't go left, I go right. Do you see the difference between these two? Do you see the physical difference between these two? Here, x squared minus 3, and here, x minus 3 quantity squared. Do you see the difference between these two? Okay, yeah, it's parentheses. So those parentheses, actually, they do a big job here. If there were parentheses, it tells me if it's happening to x. See how it's x minus 3? Versus this is x squared minus 3, x squared to x squared, not just to x, right? So, okay, so let's go. So what? Move down 3. Which one of these 5 is down 3? Which one of these 5 is down 3? What number? 1, 2, 3, 4, or 5? Which one is down 3? Yeah, it's 2. Exactly. So this answer here, I'll use rainbow pen, is the number 2. Got it? Everybody okay with that? Again, remember, your goal is to participate 2 quality times. 2 quality times, okay? Okay, so then fine. Where does this one go? Where does C go? Where does C go? Which one is C for this one? So which one looks like it moved over 3 to the right? No, that one looked like it moved 3 to the left. No, that one didn't even move. That one didn't move. Wait, this one looks like it moved 3 to the right. Exactly. Very, very good. So can you put number 4 for C, please? If you don't have the correct answer, write it now. Please, 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 please. Very good. Very good. Okay, that's done. Okay, so these 3s, do you remember we were talking, this is where we ended the last lesson. We talked about these multipliers, right? So if you think about this multiplier, this is a multiply by 3. What did we say happened to our parabola when it got multiplied by a number like 3? What did you guys call it? What did you all say? You're the one who told me this. I can show you. I can show you on this screen. Yes, it got skinnier. Do you guys remember that phrase, skinnier? So I'm going to write this here. So, hey, you made it skinnier. Do you guys remember that phrase? Skinnier, right? So that one made it skinnier. So similarly, or not so similarly, what would this kind of number do to it? What would that 1/3 do to it? Yeah, it makes it fatter. So you guys are like, oh, Miss Johnson, that's not nice. It's a parabola. I have to describe the parabola. It's fatter. There's no feelings here. Parabolas are like, I'm good. Okay, so this 1/3 made him fatter. Oh, this is the fatter guy, right? You guys all see them? So that would be 5. Okay. So then which one would be B? Where's my skinny guy? Where's my skinny guy? Ah, very good, very good. Very good. Okay. So you want me to put 3 for letter B? Is that what you want? You want me to put 3 for letter B? These two go together? Very good. Very good. Very strong work. Okay. So if you don't have these answers, go ahead and copy those answers down right now, because for those of you who've learned, this matters, right? All right. So here's what we're going to be doing today. Our focus is to write equations for functions that are transformations of f of x equals x squared. Find efficient methods for graphing transformations of f of x equals x squared. And what happens to the graph of f of x equals x squared when more than one transformation is applied, okay? So that's what we're going to do today. Again, your end goal is to be able to graph those exit tickets at the very end, okay? So let's do this first one. It says, identify each anchor point shown on the graph for f of x squared. So I think you guys did this and you did this really, really well. Yeah, you guys did this really, really well. So when we talk about anchor points, let me get here. When we talk about anchor points, we're just talking about these ones right here. You guys all see those right there. So I am gonna copy the ones from one of my classmates here because they did such a fantastic job. 0, 0, I agree. 1, 1, and -1, 1. I got 2, 4, and -2. Not -4 though. So if this is you, can you fix this? This should be +4. This should be 3, 9, and -3, +9. You guys all see that? And my line of symmetry, yep, it's at x is equal to 0. Very good. So whoever this is, if you can fix your points right there, I'm just going to copy it down as well. If you don't have this down, that's your job right now as I copy as well. Ms. Johnson, it's okay for us to copy. Absolutely. That's what taking notes is called. 1, 1, -1, 1, 2, 4, -2, 4, 3, 9, -3, 9, x is equal to 0. Okay, so far so good. Okay, the next slide says, write the equation for each problem below. Use a second representation to check your equation. The area of a square with side length x, where the side length is increased by 3 and the area is multiplied by 2, and then 4 square units are added to the area. What? It sounds like a lot of words, but they're just giving you an equation. Okay, so I'm going to write it right here. So it says the area of a square with side length x. Okay, do you guys remember how to find the area of a square? How do you find the area of a square? Yeah, it's x squared. Oh, okay. Sorry. I'm so sorry. Let me go back to line of symmetry really quick because someone said, Ms. Johnson, I don't understand it. So the line of symmetry, thank you for asking. Awesome, awesome, awesome. And we have missed you, by the way. Okay, so the line of symmetry, if you think about a line of symmetry, it's the, can you all pretend this is on a piece of paper? Where would I fold this parabola so that the right side reflects the left side? Where would I fold this piece of paper? If you said right here, oh, you can't see that line. Sorry, let me do a different color. If you said this line right here, this is my, oh my gosh, Ms. Johnson, can you just get it right? Sorry, I was trying to make it bigger. This line right here, then you're right. Okay, this is our x is equal to 0. This is our axis of symmetry. Okay, Everybody okay with that? So I'm going to pretend that you guys all know how great of a drawer I am, right? Right? Yes, someone said it's on the vertex. It's in the middle. Exactly. Good job. Thank you for helping with that. That's so, so helpful. Okay, pretend that I'm drawing my face. I know you're thinking, man, Miss Johnson, you draw so well. I know. And I know you're thinking, Miss Johnson, how could you be a teacher when you draw so well? I say to you, stop it. Okay, so here's my face. Where is my axis of symmetry on my face? Where is the axis of symmetry on my face? I know. Okay, if someone says, Miss Johnson, I know where it is. It's right here. I'd say, no, because this is not my axis of symmetry. I'm just pretending. You guys all didn't say that, but let's just pretend. No, that's not an axis of symmetry because my two eyeballs up here don't match two eyeballs down here. And my mouth down here, it doesn't match my thing down here. Okay, so Miss Johnson, that's not your axis of symmetry. Okay, so someone said, Miss Johnson, your axis of symmetry is down the middle, in the middle of the smile, between your eyes and your mouth. Yes, exactly. So my axis of symmetry would look something like that. So if you can imagine, and I didn't draw it perfectly, so just, it's okay. Imagine me folding this piece of paper. Does everybody see how the right side matches the left side? Does everybody see how the right side matches the left side? Well, that's what parabolas are. Parabolas have a line of symmetry, that's right, that goes down the middle through your vertex. Perfect, right? And then because it goes down through the middle, notice here, I had 1.11 here, and I had another -1.1 here. I had 1.24, and his matching point -2.4. Everybody okay with that? Very good. So that's what your axis of symmetry is. Okay, with that being said, now listen to this one. I know it sounds crazy, but it's not that bad. So it says the area of a square. Okay, so I'm going to draw you a square. So this is back in like, I don't know, 4th grade maybe. And your teacher says, okay, find the area of this square. What formula are you using? Someone said length times width. Exactly. So in this case, our length and our width are exactly the same. So it's 4 times 4. Okay. So what if I changed it to x and x? What would the area of this square be? What would the area of this square be? Yeah, it'd be x squared. Exactly. So, okay. So the area of the square, so I'm going to write x squared up here because that's what that means. So the area of a square, x squared, right? Where the side length is decreased by 3. What does decreased by 3 mean? What does decreased by 3 mean? Yes, we subtract. Very good. Oh my goodness. We subtract, exactly. So when we subtract, okay, now here's a question. Do I subtract the x or do I subtract from x squared? So am I going to subtract looking like this or like this? Am I going to subtract inside the parentheses or outside the parentheses? That's my question. But I'm going to read this to you again, and it'll tell you what to do. It says the area of the square with side length x, where the side length is decreased by 3. Yeah, that's right. Good job. So can you get some guesses outside? Very good. You're exactly right. Good job. Very good. Yeah, you guys are just taking risks. And if you're wrong, guess what? Who cares? You're just guessing, right? You're just guessing. Yes, it's inside the parentheses. The reason why I know it's inside the parentheses, it's because it says what is decreased by 3. Who is decreased by 3? It says the side length. And the side length is x. So you want me to write x minus 3? Oops, I don't know how to write x minus 3. Hold on. X minus 3 inside the parentheses. Right? Everybody good with that? So far, if I was to build my equation right now, it looks like this. F of x equals to x minus 3 quantity, or parentheses, squared. So far, so good? Really good job. Okay. Next, it says the area is multiplied by 2. The area is multiplied by 2. The who? Where's the area? The whole area is multiplied by 2. Yeah, it's this whole thing. The whole thing is going to be multiplied by 2, not just the x. Ms. Johnson, how did you know it was the whole thing? Because it said the area is multiplied by 2, not the length, just the whole area. So that whole area, I'm going to put a big 2 on the outside. Does that make sense? So my 2 goes here because I wanted to multiply by the whole area. Ooh, someone put an answer already out. I don't know if that's right. I don't know. Let's see. It says, and then 4 square units are added to the area. So the question again, am I going to add that area inside the parentheses or outside the parentheses? Just guess. If you don't know, it's okay to guess. When you guess and you guess wrong, guess what happens? You'll be like, oh man, I got it wrong. Oh, all right, I got to fix that before I fix, you know what I'm saying? I got to fix it. But no guess, and you'll be like, oh yeah, I would have said that. And that's not true. You would, who knows? Because you would have, then you should have said it, right? Very good, very good, very good. All right, I got a bunch of people already at 10 participation. My goodness, you are right. It is on the outside. Ms. Johnson, why is it on the outside? Because did you add 4 units to the length? Or did you add 4 units to the area? I added 4 units to the area. Do you see how that works now? Got it. Good, 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 good. Okay, here, question. So if you've been following along with me, you should be able to be like, oh, I know what that 4 is going to do the function, Ms. Johnson. Ms. Johnson, I know what that -3 is going to do that function. Ms. Johnson, I know what that 2 is going to do the function. Right? So can you imagine that really quick? Can you imagine what each of these numbers do to the function? Because that's all we're doing right now. That's all we're doing today. If you already know how to do that, you're already like, you know, you got the goal for today. Now it's just practice. Okay. All right. So number 3, it says write an equation for each of the problem. Use a second representation to check your equation. So I would graph this. I would use a table on this. Oops, I'm not on the wrong page here. Okay. So this one here, I'm going to do as well, right? So this one here, let's see. I'm going to have you try doing this equation, writing this equation on your own, okay? Now that you have some remembering of this, right? I'm going to remind you really quick. Let's just do this one really quick. If I was to graph this, what would that 4 do to my function? If I was to graph this, what would my 4 do to my function? Yeah, that 4 makes it go up. Awesome. Awesome. Very good. Very, very strong work here. I'm like having a hard time squeezing all of your participation points in here. That's funny. So that 4 would move it up 4. This 4 moves it up 4, right? Okay. Yeah. No, that's good. No, you're supposed to, like, if you don't know this, that's your job right now. Your job is to learn this. Don't worry. Wait, what? The problem that was just, yes, this is this one. Okay. What would this 3 do to the function? What would this 3 do to my parabola? Yeah. Very strong work. Very strong work. Hey guys, put it to the public chat, y'all. Because otherwise you guys think that I'm talking to myself. I'm not talking to myself. These are so funny. Very good. Very strong work. Very good. Okay, yes. This would move it 3 to the right. So already you want me to move it 4 up. Boom, right? 1, 2, 3, 4. And 3 to the right. 1, 2, 3. Good. Last but not least, what does that 2 do? What does that 2 do? What does that 2 do? Do you remember? Yeah, it does multiply. Yes, Nathan, that's exactly what I was looking for. It makes it skinnier. It makes him skinnier, right? Very good. Very, very good. Very good. All right. Okay, moving on. All right. So with that, I want you to pause right now and try to do this one on your own. Okay. Okay. So when you did this, how did you guys do this? What did you do first? Did you do the number inside? Did you do the number outside? Give me a second. Okay, I got a couple answers in the chat, and it says like this is what people have written: x minus 3 quantity squared minus 1. Another person put 2 parentheses x minus 1 squared plus 4. And then someone else said x minus 3 because it moves 3 to the right. I agree. I agree that it moves 3 to the right. Where do you see the 3 to the right? Someone else. You guys are doing fantastic, by the way. So I see it moving 3 to the right like this, because before my my original guy, x squared, has his vertex at 0, 0. Oh, okay, plus 3, got it. Someone said, I didn't mean plus 4, I meant plus 3. Okay, so then it moves 3 to the right. 1, 2, 3. And because I'm moving 3 in the x direction, hint, hint, x direction, right? X direction. When I move in the x direction, it's backwards. That's why it's minus 3. So over here, I've got this meaning right 3, right? So this guy moved right 3. Do you guys all see my right 3? Very good. Very good. So this minus 1 is not correct. This needs to be fixed to minus 3, right? The squared looks correct. And then I need to go, I need to move down 1. Boom, I moved down 1, okay. And so that's why that plus 1 makes, the minus 1, sorry, down 1. That's why the down 1 makes sense. Let me move Scoochie over a little bit more. Scoochie over, there it goes, down 1, boom. Everybody okay with that? And the last thing is this person put a 2 right here. How would I check this? Anybody know how I could check this? How would I check my answer between if I need a 2 here or not? So just like this one, we're gonna find a couple points to check. So I can't check my vertex because I already know my vertex is gonna be right. I'm gonna check another good point. Does anybody see a good point that I can check? Does anybody see a good point that I can check? Yeah. Someone says 2, 1, Miss Johnson. Exactly. So what I'm going to do is I'm going to plug 2, 1. I'm going to plug in 2, actually. I'm going to plug in 2, and I hope I get out 1. If I don't, then that just means I need to adjust. Okay. So I'm going to plug in it using my calculator because Desmos is my friend. And then I can actually check my graph at the same time, right? So here I got parentheses 2 minus 1 close parentheses squared, right? And then I'm going to hit -1. Oh no, it's a 0. Shoot. So it's not a 1 right there. Okay, so someone said, Miss Johnson, try that too. Oh, yay, 2, 1, it works. So I have to add this 2 here. So does everybody see where my 2 came from? It was my multiplier. Very good, very strong work. Very strong work. Okay, so what I'm gonna do now is I'm gonna graph this and see if I get the same thing. So here I go. I'm gonna use this as X. And let's see, I'm gonna zoom in a little bit. Oops, too much. I think I zoomed in too much. There you go. Okay, so wait, oh, I put it wrong. It's -3. Hold on, guys. Okay. So I copied my equation down wrong. It's a -3 right here, right? So if I did that, do I still get a 2? See, I still get my 2, which is very exciting. So this is actually my equation. I'm going to check a couple points here. I got 0. I got 3, -1, check. I've got 2, 1, check. So this is my function. I did it right. So whoever put this one, you were right with the 2. Awesome work here. How did they know that, Miss Johnson? There's a couple probably things that tipped them off that they needed that to be a 2 because your anchor points look like this, right? 1, 1, right? It wasn't 1, 1 away, right? That was one of the little tips that they came up with. The other tip too is you always want to check some of your points to make sure. Okay. Okay, so for this one looks a little bit on the crazy side. Anybody notice anything here? The first thing I want you to do whenever you're looking at a table, I want you to look at, I'm gonna ask you to look for the symmetry. Does anybody see my symmetry here? Does anybody see my symmetry? Where do you see the symmetry? Exactly, with the -1s, right? Ms. Johnson, I see symmetry with those -1s right there. See, -1s, they matchy-matchy. And then with the 2s, Miss Johnson, see, with the 2s, do you see the 2s, Miss Johnson? They matchy-matchy. And then with the 7s, Miss Johnson, do you see the 7s? They matchy-matchy. So can you imagine they're gonna go like that? Like the 7s are gonna match, the 2s are gonna match, the -1s are gonna match. You guys all see that? Okay. So the very first thing I want to do is I just want to graph these numbers on a table because it just makes it a little bit more like, oh, I get it. So that's what I would probably suggest you to do first is actually graph it. You don't have to use Desmos. You can actually just put it out there like that. -1, -2, -1, 2, 7, 14, 23. Okay, so let me turn this guy off. And do you guys all see my parabola? Do you see his little shape? So now that I have his shape, now I can talk about those shifts. Now, if you got the shift wrong before, who cares? Try again. Okay, so I want you to try again. I'm going to put my little form out here. Oops. Right, and I got. So I'm going to pause it again, and I'm going to have you try putting your shifts in, right? And then see if you can get as close to the function as possible. I'm going to pause. Okay, so what shifts did you see? What shifts do you see for our table there? There it goes. What shift? What's the first shift that you saw? Yeah, I saw down 2 too. Okay, so someone said, Miss Johnson, I see the down 2. Where does the down 2 go? Inside my parentheses or outside? Inside or outside? It actually goes outside. Down 2 is outside. Y direction is always going to be outside. Very good, very good, very good. Now, again, if you don't get this perfectly, that's the way it's supposed to be. You're not supposed to get everything perfectly. No worries. Okay, what other shift do you see besides the down 2? What other shift did you see? Yes, left 1. Now, left 1 goes inside or outside? Left 1 goes inside or outside? Inside, very good. Now, do I put -1 or do I put +1? Do I put -1 or +1? Yes, very good. Very, very good. Very good. So this is going to say x plus 1, Miss Johnson. Exactly. Now, I could already tell there's no stretch here because it's my anchor points are right there. You see the 1, 1. It's 1, 1 away from my vertex. Perfect. So this is actually my function. And so I can prove that by going like this. Watch. When I plug this in, x minus plus 1, plus 1 quantity, oops, what happened? Squared minus 2. You see what happened right there? My red function went through my dots. You guys all see that? So I know that I'm right. Okay, here's what I need you guys to do for homework today. Can you do the rest of Desmos? Where's my Desmos? Can you finish Desmos? Now can you look at 5 and 6 and 7 and 8 and 9 and 10 and 11? At the same time, can you also go back to 2.1 and try those problems that you asked? Because now you have some greater understanding towards that lesson. Does that make sense? So I'm going to guess the person who asked the questions here for our check-in, right? The person that asked these questions, I'm going to guarantee that now when you go back to those questions, it's not going to be as difficult, right? All right. Other than that, I am going to see if you guys have any questions. I'm so impressed with how well you did today. Litzy, I know you've been gone for a couple of days. You really impressed me today because you asked a question, you jumped right in. Go back and watch that 2.1 lesson because I think that'll help you gain better understanding. But my feeling is now you're kind of caught up because of the way you answered. If anybody has any questions, I need you to stay here and be like, Ms. Johnson, I'm so frustrated because I don't have the grade that I want. Reminders for you really quick. Number 1, the extra credit that I talked about in the beginning of the period, due on Friday. Okay. Today I changed your assignments around a little bit so that your 2.2 is going to last us for Friday as well. Okay. All right. Any other questions for me? Hang out. Otherwise, I'll see you guys later. Bye, guys. Bye, Jaylene. Bye, Lisa. Isaac, did you have a question? Isaac.
Yeah, I just had one question, one quick question. I heard you say that my grade will go up by 2% with the 5 point.
Yeah, as long as you submit it. Did you submit it yet?
I was gonna ask you that also. Like, how do I submit it? I copy and paste it, right? Yeah.
Just the URL.
Okay. And also, I talked with my advisory teacher because she told me like to look at my grades and she saw my grade for math. And like she asked me if I could redo the quiz, and I was like, yeah, I just gotta let her know. And so like that, I wanted to know like when can I redo the quiz?
So here's what I want you to focus on. I want you to focus on this stuff first. Okay.
Because I want to do it like before like grades are actually due because I want mine.
No, that's not gonna happen. Sorry.
Okay.
Yeah. I'm gonna hold. It's probably gonna be one day in October. Any retakes you want to take, you're gonna have to show up that day, right? So it's not gonna happen before my grades are due, which is on Friday. Remember, I told you guys that my deadline was yesterday.
Yeah.
So what I want you to do is I want you to focus really hard on what you're learning right now. because that's the level in which you need to understand last unit's stuff. If you
Okay.
don't have that level of understanding, you're going to take that test, that quiz again. Does that make sense?
Okay. Okay. I understand.
All right. I'll see you later, buddy.
Thank you. Bye.
Bye.